Alright, so before we start for today's session, you boleh tengok dalam U Future, right? I dah letak data set, right? For chapter number 3, kita tengok week number 8, right? 23rd May until 29 May, right? Dalam ni I dah letak chapter number 4, data for chapter number 4, ada 2 data. And then another one is data for chapter number 5, I ada 6 data. Right, yeah, you boleh download the data first before we start our session. Sementara kita start the session ni, boleh download the data dulu lah. And then don't forget to sign in your attendance. Right, attendance make sure sign in lah. Right, yang mana belum sign in dulu. Right, sekejap ya. Okay, so for today's session kita nak tengok dua chapter number 4 and chapter number 5. Right, first chapter chapter number 4 is Descriptive Statistics using Microsoft Excel, and chapter number 5 is Inferential Statistical Inference. Right, Statistical Inference. So both require Microsoft Excel lah. Kita akan tengok menggunakan Microsoft Excel. Alright. So for descriptive statistics using Microsoft Excel, right? Kita tengok what is the definition of statistics. Right. So, right. Are you ready? Kita tengok definition of statistics first. This is about most of first lecture ni about theory lah, right? Definition of statistics is about dealing with the data, right? So how information is being collected. Information currently commonly known as data lah, is being collected, organized, and then analyze the data, right? And then once you already analyze the data, we got the result, then we interpret the result and present the result. So this is the definition of statistics. Definition again, I ulang. Definition of statistics is how information, you boleh tulis kalau you tak sempat, how information commonly known as data is being collected. So kita nak tengok macam mana data to being collected, and after we already collect the data, then we need to organize the data in proper form, either in a database or in spreadsheet lah. And then once you organize the data, then we need to analyze the data in descriptive statistics. Kan tunjuk dia punya bar chart ke pie chart, or we need to we do inferential statistics using a linear regression ke, one way ANOVA, t-test and so on. So then after we analyze the data, we got the result, and then we interpret the result. So we interpret the result so the layman can understand the result obtained from the analysis. And once we already interpret the result, then we going to present the result in a proper form lah. So so we present the result so then people can understand, right? Alright. Kejap. Right. So next we look at the type of statistics, right? So there are two types of statistics, right, that we're going to learn for today. First type is descriptive statistics. Another one is inferential statistics. So descriptive statistics, we just describe the data, and inferential statistics, we're going to take a sample from a population and infer back to the population. So we're going to make an inferential conclusion. So descriptive statistic, kita tengok the procedure technique for descriptive statistics. So descriptive statistics actually tadi I sebut kita nak describe the data. We want to describe the data, either what is the maximum value, what is the minimum value, what is the average, what is the standard deviation, and so on lah. So the procedure consists of technique for summarizing data. So kita ada beberapa procedure lah yang kita boleh tengok dalam descriptive statistics. First, either in using graph, chart or table, right? With table selalunya kita akan tengok dia punya distribution. What is the minimum value? What is the maximum value? What is the type of distribution? And for numerical summaries, we have mean, median, mode, variance, and standard deviation, right? So I think you're already familiar with mean, mode, median, and variance and deviation, right? So kita dah belajar this one since tingkatan 5 lagi, right? Dalam SPM, right? Mathematic, I think Math Modern, right? And at Math, kita dah belajar mean, mode, median, variance, and deviation. So for example, if you are studying the monthly pocket money obtained by 200 students selected from a total 1,500 students in college, so we might want to know the average monthly pocket money obtained by the students. So finding the average monthly pocket money itu adalah example of descriptive statistics. We just want to know what is the value, right? Average secara puratanya berapa monthly pocket money daripada 200 student ni, right? So before we go further, let's look at the basic statistical term, right? So we need to understand the basic statistical term before we go further, right? First term yang kita nak tengok adalah population. So population ini adalah complete group consists of individual, object, item or measurement to be taken for the purpose of the study or survey. So the size of population may be small, may be large, depending on the objective of the study lah. Right? For example, let's say I want to study a knowledge, attitude and practice on dengue fever prevention at Perak Tengah district. So the population will be the whole residents in Perak Tengah district lah. All residents in Perak Tengah districts. So semua penduduk di Perak Tengah district lah. Another example, let's say all lecturers in UiTM Cawangan Melaka, all bachelor student in UiTM, all houses in Taman Demensi, all trees in the park, age of all student in the class. So population ni means all member in the area of the study lah. Right, so let's say kita punya another example yang I boleh bawa, let's say I nak buat study about satisfaction of food at cafe, at UiTM cafe lah, UiTM cafe. So this is my study, let's say. So I nak study population at UiTM cafe, let's say UiTM Tapah lah. The population will be all students in UiTM Tapah lah. Let's say for example n equal to 5,000. So there are 5,000 students in total in UiTM Tapah. So population will be all students in UiTM Tapah. Right, another term that we're going to look is sample. Sample is a portion taken from a population. A portion taken from a population. Why we do sample? Because if we have very large population members, right, it is imperative to take all member in the population lah, because it will cause labor cost, lagi kita nak kena hire orang kan, labor cost, lagi masa kita kena spend masa untuk collect the data if you taking all member in the population kan. And then we need to train the data collector kan, untuk collect the data. So it will cost a lot of money, time and labor lah. Right. So that's why we take a portion, right, a sample from a population. So this is what we call a sample lah. We take some members in the population. So this is what we call as a sample. So sample can be either randomly or non-randomly. So dalam statistik ni kita ada dua method lah untuk select sample. Let's say if you want to select random sample, it will reduce a selection bias lah. Kalau kita buat a non-random sample, maksudnya kita just distribute the questionnaire, so it will rise the biasness of a selection bias, right? So kalau kita tengok example dekat sini, there are 60 lecturers in UiTM Cawangan Melaka. So kita kalau population all lecturers, sampel kita ambil 60 saja daripada semua lecturers di UiTM Cawangan Melaka. So 80 bachelor student in UiTM Melaka, double story terrace houses in Taman Dimensi, right? So imagine in Taman Dimensi we have many type of houses, let's say single story, double story, right? Ada bungalow, right? So we are selecting double story saja. So that what is a sample lah. So now let's look at another term which is a sampling unit. So sampling unit is a sample that has been selected from a population randomly or non-randomly. So let's say kita ada tadi example kita satisfaction of food in UiTM cafe kan. So let's say our population capital N is equal to 5,000. So we have a list of 5,000 students. Let's say 1, 2, 3 until 5,000. So we decide we want to take, instead of taking all students as a consideration, so we just take a sample, a portion of student, let's say N equal to 100, right? So if you are using a random sampling method, let's say kita select nombor 2 ni untuk jadikan kita punya sample. So 2 ini, orang yang student nombor 2 ni, ini dipanggil sampling unit. Right, boleh faham ah? So this is a sampling unit lah. Another term is sampling frame. Sampling frame is a list of all members in the population. So in this example lah, kita tengok example ni. So we have 5,000 student in UiTM Tapa. So we to select 100 student using a random sampling method, so we need a list of all members, all students in UiTM Tapa lah, from number 1 until number 5,000. So this list should consist of their information lah, such as name, right? Name, student ID, phone number and so on lah. So apa tujuan kita ada information ni? Senang bila kita nak select members, select sample ni, let's say sample number 2. So senang kita nak contact the sampling unit, right? So another example, kita tengok dekat sini, some example of sampling frame. Some example of sampling frame are list of all of student names in class, list of college name in UiTM campus Alor Gajah, list of companies registered at KLSE, right? List of name and address of the subscriber in the telephone directory, and list of name and address of voter of electoral register. So this is a sampling frame. So means that we need to have a list of name, a list of all members in the population, right? Boleh So next kita tengok random sample. So random sample means that we consider every members in the population has an equal chance or probability to be selected as sampling unit. For example, kita ada tadi I sebut a sampling frame. So we have a list of all members, all students in UiTM Tapa. Let's say number 1, number 2, number 3 until 5,000. So each member have an equal chance of being selected, 1 over 5,000. Number 2 also have a probability of 1 over 5,000. Number 4 also have equal probability 1 over 5,000. Right? So semua ni ada equal chance of being selected if you are using a random sample lah. Right? So census ni maybe you all dah selalu dengar. Census is a banci lah. Is a survey that takes all members in a defined population. If you have a 5,000 student in UiTM Tapa, so we take all members in UiTM student lah, all student in UiTM Tapa. So this is what we call as census lah, ataupun banci. So thing to note is census is normally taken if the population to be studied is small lah. Right, kalau kita national census tu maybe government have dia ada kekuatan untuk ambil semua kan. Even that dia tak ambil semua juga, dia ambil targeted kan. So and then dia project to be the sum of the sample to be normal, right? And then kita tengok lagi satu term, we have a sample survey. Right, this is another term, sample survey, a survey that takes only a portion of the population. Right, it's sama juga konsep dengan sample. Right, we take a sample from a population. Right, so sample survey ini dia best done is the population size is very large or large lah. Right, another term is a pilot survey. Alright, things to note that pilot survey is not a study about aircraft. It's a study that carried out before actual survey. The survey that's carried out before the actual survey lah. Maksudnya, before we go for the actual survey, let's say we design a questionnaire, we need to test either whether our questionnaire is reliable or not reliable. Is it valid or not valid? Right, so we need to do a pre-testing. Right, so to test whether our questionnaire is okay or not. Sama juga if you are launching a new product, right, you need to test whether your product is reliable ataupun tak reliable. Contoh macam if a pharmaceutical pharmaceutical company, they nak create a new drugs, right, for some disease kan. So before they create a new drugs ataupun new product, right, they need to do a feasible test kan, ataupun product testing. So dia akan test berapa lama dia boleh duduk dalam plastik tu, and then is there any side effect, ataupun bila dia dah berapa lama dia akan expired. So dia akan test semua tu sebelum dia make a actual production lah, right? So this is about pilot survey. Now we look at another term. This is a very important term, which is statistic without S. Remember, this is a statistic without S. Just now in the first slide, I showed to you, right, the definition of statistics. This is a statistics with S, right? Statistics. So the definition of statistics is a study on how information commonly known as data is being collected, organized, analyzed, interpret, and present. But for statistic without S is a numerical summary. Right? It's a numerical summary taken from sample. Taken from sample. Right? Let's say you want to measure mean from the sample. So the symbol for mean is X bar, median is X tilde, and mode is X hat. So this is a symbol for statistic. Means that we are calculating the mean from the sample, right? So whereas the parameter is a numerical summary calculated from population. If you want to calculate mean of the population, the symbol will be mu. The standard deviation is sigma. Right? The standard deviation for statistic is S. Right? So there is a different and the formula also different for standard deviation. Right? So now let's look at the statistic versus parameter. Right? So this is a population parameter symbol, and this is a symbol for sample statistics. Let's say we want to calculate mean. The symbol for mean for parameter is mu. For mean for parameter is mu, and the symbol is mu. Mean for sample statistic is X bar. Mean for proportion for parameter is pi. Proportion for sample statistic is P. So there is a difference kan. So but the only thing formula same adalah mean lah. So 1 over n summation of xi. This is for small letter n is for sample. Capital letter N is for population lah, xi. So this is a formula, right? This is a formula for mu, and this is a formula for x bar, right? Okay. Sama juga dengan correlation. For parameter, right, we are using rho. For sample, we are using R, right? For regression, beta, the capital letter beta, and small letter beta for sample statistics. And then the thing that we need to understand is variable and data. So variable is the measurement or characteristic of interest. Means that something that we want to measure. For example, age, marital status, gender, lagi apa, income status, right, and so on. So all of these are we call as variable, right? So the value inside the variable, which is let's say age kan, kita ada this is let's say age. Age is a variable, right? So the value, let's say 18, 54, 48, 38, 24. So this is the value. The value inside consists for the variable ni we call as data lah. So this is what we call as data, and this is what we call as variable. So it is important to understand the term that I already introduced here, because most of the time bila kita dealing with the data analysis, we need to understand that we need to differentiate what is a variable, what is the data, right? So variable, so ini banyak sangat nak tulis kan. So now you can boleh ambil satu kertas, right? Tulis this one, right? So we know that we already know the term variable, right? So the variable can be two parts, right? Can be divided into two parts. The first one is qualitative. Another one is quantitative. Right? Variable can be two parts. First is qualitative, another one is quantitative. So quantitative is a numerical. Means number lah. Itu kita punya example, let's say height 1.65 meter, 1.75 meter, right? So itu adalah numerical kan. So qualitative, something that we cannot measure, but we can identify. For example, this is what we call as a categorical data. Ataupun categorical variable lah. So something that we cannot measure, but we can identify. For example, gender. It can be either male or female. Right? Ini example di sini adalah, let's say height. Let's say 1.72, 1.70, 1.63, right, meter. So something, any numerical value, right, it will lies under quantitative. Boleh faham? So under quantitative variable can be divided into two parts. First part is a discrete. Another one is continuous. Right? So we know that quantitative is a numerical value. Something numeric, right? Ada numbers. So dalam quantitative ni can be divided into two. First is a discrete, and the one is continuous quantitative. Discrete quantitative, continuous quantitative. Discrete quantitative is a value that contain whole number, right? Whole number. For example, 1, 2, 3, 4, 5, and so on lah. Continuous quantitative, it consists decimal lah. Right? Any value within range are possible from 0 to, let's say, 100. So from 0 to 100, 0 0.1, 0 0.001, 1.35, and so on. Semua ni adalah values under some range lah, some interval, from 0 to 100. So example of a discrete, for example, right? Discrete ni senang saja nak identify. It's a numerical value that we cannot measure, but we can count. Right? Kita boleh tulis ni is a numerical value that cannot be measured, but we can count. For example, let's see, I make color apa. Okay. Example, number of children. Right? Number of children, either 1 or 0, 1, 2, 3, 4, 5, and so on lah. Right? Number of accidents, number of students, right? Something that we cannot measure, but we can count, right? So it lies under quantitative. Continuous quantitative is something that we can measure lah. For example, height, right? Weight, right? In a number of kilometer ride by using car, right? Kilometers, kilogram, and so on, right? Something that we can measure with using a SI unit lah. So I hope you understand the difference between qualitative and quantitative, right? Under variable we have qualitative and quantitative. So under this variable, we have scale of measurement. Scale of measurement. So we know that qualitative is a categorical variable, right? So we know that qualitative is a categorical variable. So it can be divided into two parts. First is nominal scale. Nominal scale. Another one is ordinal scale. For quantitative, it can also be divided into two parts. First is interval scale. Another one is ratio. So all of these are available in your book lah. Ada dalam buku, you boleh baca. But I am explaining to you so you can understand. So nominal and ordinal lies under qualitative variable, right? So we know that this is a categorical variable, right? So we cannot measure, but we can identify. For example, male, female, ethnicity, Malay, Chinese, Indian, right? Colors, yellow, blue, red, pink, and so on. So what differentiates between nominal and ordinal? Nominal is a categorical variable that cannot be ranked, right? It is a categorical variable that cannot be ranked or ordered. It cannot be ranked or ordered, or in order lah, or in order. For example, gender, male and female. So it cannot be ranked. We cannot say that male is number 1, female is number 2. We also cannot say that female is number 1, male number 2. Okay? So it cannot be in order. So another one is ethnicity, right? Malay, Chinese, Indian, Siamese, and so on. So you cannot say Malay number 1, Chinese number 2, cannot be in order kan. So since this cannot be in order or cannot be ranked, so it lies under nominal scale. For ordinal scale, nama pun ordinal, it should be in order lah. So example, committee member. So let's say president, vice president, secretary, treasurer. It should be president number 1, vice president number 2, secretary number 3, treasurer number 4. Right? It cannot be treasurer number 1 followed by vice president, president, and secretary. It should be in order. Right? Another example is income status. Right? Low income, middle income, high income. So it should be in order, right? Right. And another one is, let's say, satisfaction. Let's say age kan? Age. For example, less than 20 years old, 21 to 22 to 30, 31 to 40 for example, and so on lah, more than 40. It should be in order. Maksudnya mesti ikut turutan. So something yang boleh ikut turutan and mesti in order, it should be lies under ordinal scale lah. So interval and ratio, it is lies under quantitative variable, right? Quantitative variable, we know that this is a numerical value. So both are taking numerical value. So what differentiate between interval and ratio? Interval is a numerical value, numerical data, right? That 0 is not a true 0. 0 is not a true 0. For example, temperature, 0 Celsius doesn't mean there are no temperature there. So bukan kan? 0 Celsius mean maksudnya takat beku kan? So dia bukan tak ada suhu dekat situ, right? It means something else. 0 Celsius means something else. So it's not a true 0. So it lies under interval scale. And the distance between this numerical value is not a true distance, right? Maksudnya, adakah 10 darjah Celsius dengan 20 darjah Celsius, ada 20 darjah Celsius tu lebih panas daripada 10 darjah Celsius, 2 kali panas daripada 10 darjah Celsius, kita tak boleh tell kan? So it's not a true distance kan? Dia tak boleh kira the difference of the distance. And ratio is a numerical data. Sama juga, we know that these two are numerical data. Ratio is 0 is a true 0 lah. 0 is a true 0. We can calculate the distance, we can calculate the difference between two numerical data lah. For example, height, weight, right, money, right? So if you have no money, means that you have no money kan? So it's a true 0. So I hope you understand the difference between nominal, nominal, ordinal, interval, and ratio. So based on these 4 level of measurement, so less information, more information. So a ratio has more information, nominal has less information, because this is a categorical data. Right, we have less information. So I hope you understand the definition of variable and qualitative and quantitative variable. Under quantitative variable, we have a scale of measurement in nominal, ordinal, interval, and ratio. Right. So any questions so far before we proceed to measure of central tendency? Right. I hope you understand. Right. So now, let's look at measure of central tendency. So under measure of central tendency, we have 3 measures. First is mean, median, and mode. So mean is the average lah, ataupun bahasa Melayu kita kata purata. Median is a middle value, middle point. Mode is the most frequent value to occur. Right. For example, this is the formula for mean, right? So summation of x might divide by n. So x is a total value or observation in data, right? Divide by number of observation, right? So sama juga for categorical data and for group data ataupun ungroup data. So median is a middle value, right? So how to interpret median? So median is a middle value of the arranged data in ascending order. So before we calculate the median, we need to arrange data in ascending order from the smallest value to the largest value. And the interpretation of median is 50% of the total number of observation having value less than median value. So kita ingat median is the middle value. So let's say from 0 to 100. So this is going to be 50% lah. So 50% of the median value less than median value. Another 50% of the observation is larger than median value. So mode is x hat is the most frequent value to occur, right? So this is what we call as mode lah. So now in Excel, we if you want to calculate mean, median, and mode, so this is the formula, right? In Excel, for calculating mean, we are using average. For median, we are using median. For mode, we are using mode dot single. This is for a single data lah, not SNGL, right? For to calculate the mode, right? So all of these formula are available in your book lah. You boleh tengok dalam buku, right? Another one is a measure of dispersion, right? Ataupun range, right? So the importance of understanding the range ataupun dispersion is very important to differentiate two or more distribution. For example, let's say I am collecting data at two playground. So let's say playground A and playground B, right? So in playground A, I collect 10 data, right? And playground B, I also collect 10 data, right? So playground ni, I pergi collect data apa yang nak collect? Let's say age of the children. So let's say I collect the data, I dapat macam ni. And then the distribution x bar is equal to, let's say 5, right? Another one is playground B, I collect the data, I dapat macam ni, right? So a bit tinggi, right? And the mean is also equal to 5. So we want to know which playground has a consistent age of children. So kalau kita tengok dekat sini, data dia lebih mencapah. So maybe dia ada umur 1 tahun atau less than 1 years or more than 10 years. Dekat sini, distribution ni, kita boleh tengok dia lebih sempit kan. So maybe dia dekat sini umur lebih kurang 3 ke 7 tahun saja. Right? So that's why to know the different or the dispersion or spread of the data, so we need to accompany the data. Instead of having a single mean, we need to accompany the data with the standard deviation or variance, S square or S. Right, sama jugalah. So this is range. Range maksudnya maximum value minus smallest value lah. So variance is standard deviation is the mean of the difference of the data around the mean. Right, maksudnya let's say this is the observation, so kita ambil the difference, right? Right, the difference and the difference. So we want to measure the mean square. So the measure of, maksudnya kita ambil mean of different from observation and mean, and we square, right? So this is what we call as standard deviation. So in Excel function, right? So if you want to calculate range, maximum value minus minimum value. So for population variance is variance dot p, sample variance variance dot s, standard deviation st def dot p for standard deviation for population. Kita tambah s untuk sample. Z score maksudnya standardized x mean and standard deviation lah. Z score ni adalah uh, x minus mu divided by sigma lah, right? So this is a Z score, but kita akan tengok ini dalam next chapter, right? For standard coefficient of variation, right? Coefficient of variation, contoh tadi kita ada dua distribution kan. So if you want to know which distribution is more consistent and which distribution has more spread, right, we need to have these two value lah, x bar and sample standard deviation, right? So we are using a coefficient of variation, right? So coefficient of variation is standard deviation divided by mean multiplied with 100%. So which standard deviation yang kecil, so itu melambangkan dia lebih konsisten ataupun less spread. Kalau yang coefficient of variation ni value-nya besar, maksudnya dia more spread and more dispersed, right? So I hope you understand. So now let's look at the data, sample data yang I bagi. Let's say kita tengok purchase order with transaction, right? Purchase order transaction. Chapter 4. Data chapter 4, purchase order transaction. Right? Okay. Take your time. So once you're ready, beritahu, okay? Okay? Alright. So kat sini kalau boleh nampak ya, ada letak satu kotak kat bawah ni kan. So, right? So to calculate mean of order amount, kan kita tengok order amount dekat sini. So kita letak, boleh nampak Kau nak besar lagi. Right. Ini cukup besar So besar sikit lagi. Right. So dekat sini mean of order amount, kita just letak average, right? And then kita tarik dia daripada sini ke atas, right? So sampai G4 to G110. So we will get the average ataupun mean of order amount. So I hope you're paying attention on this because you akan pakai this one for your project. Alright, to calculate mean, so you just type average G4 to G110. So this is a conventional method lah. So nanti I tunjuk dekat you menggunakan analysis toolpack method. Right, so you just enter, you akan dapat. So this is the amount, average order amount, right? So the formula is average G4 to G110. You just select this one. And from the G110 to G4. So you will get that one. So for median, very simple. You just type median, right? Sama juga G4 to G4 to G110 lah. Very simple. I think most of you can do it dah. Boleh? topik hari ni sangat berat. So I hope you can pay attention. Nanti lepas ni kita rehat 5 minit untuk refresh for next topic, chapter number 5. Sudah? And mode is M-O-D-E. Kalau you type mode saja, you type mode dekat sini, you nampak tak ada 3 drop down menu dekat bawah. Just type mode, right? Ada mode multi, mode single and mode. So kita ambil mode single lah, since kita nak ambil single data saja kan. So mode single sama juga. So G4 to G110 lah. So dia akan bagi the most frequent order amount value, right? So kalau kita hit enter, so dia bagi tahu 5887 is the most frequent. And the variance, the range is very simple. You just type maximum of G4 until G110 minus minimum G4 until G110, right? Range means that kita nak maximum value minus minimum value lah, right? Very simple. Okay. Boleh ikut? Alright. The next one is variance. We just type variance. So kalau kita type VAR dekat sini, dia akan keluar drop down banyak sangat. Right, kita ambil var.s. Maksudnya kita nak for sample. Right, var.s G4 until G110 lah. Right. So kita akan dapat variance. Right. So variance dia besar sikit, kena tarik keluar. Right. Okay. 1 million. This is billion already. 1 billion. Right. So for standard deviation is basically it's a square root of variance lah. A square root of variance. Ataupun kita tak mau pakai square root of variance, kita boleh type STD EV. Right. Standard deviation. So dia akan keluar banyak dekat sini. Kita ambil standard deviation for sample. Sama juga G4 until G110 lah. Okay. Boleh So we will get a standard deviation. Right. Sekali lagi. Standard deviation STDEV.S. This is a standard deviation for sample. Right. And then we select the data. Right. So this is a conventional way, right? But this is very good as well, right? Kita boleh get the data dekat sini by manually key in the value lah. So in Excel we have yeah. Dekat mana? Right, dah kan? Oh, formula ni nampak dah? Okay. Alright, good. So, next, kita tengok, instead of typing the value kan, let's say we still want the minimum value, maximum value, range, mode, standard deviation and so on. So, there are one function dalam Excel, kita just select the data, they will give us all the statistics. So this is what we call as data analysis lah, dekat sini. Kalau you still remember in previous video, I letak short video dalam U-Future tu, I ada letak how to install analysis tool pack. So kalau yang belum install, kalau you pergi ke tab data ni, you tak nampak analysis data analysis kat sini. Semua ada data analysis kat sini ke? Ataupun ada yang tak ada? Alright, if you don't have, so now you pergi ke file, tekan dekat file ni, right, you turun ke bawah, cari option. So this is very important. You need to do, because the next chapter we need to use this, right? So click option, right? So dia akan keluar Excel option dialog box, right? So you tekan dekat, you cari dekat hujung ni, cari add-ins. Add-ins. So yang mana dah ada, you akan nampak analysis toolpack dekat atas ni, active application add-ins. You akan nampak analysis toolpack. Right, yang mana belum ada, right, you pergi ke bawah ni, yang belum ada dekat sini kan, you pergi ke bawah ni, manage, dia ada banyak add-in kan, you tekan Excel add-ins. You cari Excel add-ins. Right? And then you tekan go. And then dia akan keluar macam ni. So dia akan keluar beberapa lah, ada 3, 4 add-in. So you tick analysis toolpack. You tick analysis toolpack and click OK. So automatically dia akan keluar data analysis dekat sini. Dekat data. Dekat data tab, dia akan keluar data analysis. So I hope you already have it. So ada yang belum ada? Ada yang belum ada? Semua dah ada? Can you respond? Right. So first you go to file, and then kat bawah sekali ada option. Dah tekan? Semua orang kena ada benda ni ya. This is a must. Kalau tak ada nanti next chapter tak boleh buat. Yang kita nak masuk Inferential Statistics ni tak boleh buat nanti. And dalam report you pun mesti kena buat Inferential Statistics kan. Mesti kena ada pakai benda ni. Kalau tak susah nanti. Atau you kena beli software SPSS ke benda lain kan. So dah dapat ni. Dah sampai stage yang sama. Can you respond? Yang lain macam mana? Ada, okay, good. So you pergi ke general, dekat add-in dekat bawah ni, right? So make sure you tengok dekat atas ni, active application add-ins. So kalau you tak nampak analysis toolpack dekat sini, kalau you nampak lah, kalau you nampak analysis toolpack dekat sini, maksudnya dah ada lah. So don't worry, right? You just cancel kalau dah nampak. Kalau tak nampak lagi dekat active application, right, you pergi ke bawah ni, cari Excel add-ins. Dekat manage ni, kat bawah sekali, Excel add-ins. So you tekan go, right, and then you akan nampak add-ins available. So you tick dekat sini. Make sure you tick. Nampak tak I tick kat sini? Nampak tak? Dekat sini. Kan? Tick dekat sini. And then click OK. Right? Click OK. Once you tick, then click OK. Okay? Kalau macam I punya dah ada, I just cancel lah. Right? So, bila you click OK, you akan nampak dekat data ni, kat home, data ni, kat hujung sekali, you akan nampak data analysis. So, data analysis tool for financial and scientific data analysis. Kalau tak ada, kalau you jenis macam ni kan, macam sepatutnya adalah I kecilkan ke I punya screen yang monitor yang kecil pun mesti ada. Kalau tak ada, you boleh tengok dekat hujung. Dia ada macam arrow kat hujung ni. You boleh tekan sampai hujung. You akan jumpa juga akhirnya nanti. Semua dapat? Nurul Hafizah, okey? Or you want to share your screen? If you want to share your screen also can. Dah hilang. Why not you share your screen? I can see. Share your screen. Right. So once you ada data analysis dekat sini, you just tekan data analysis. Dekat sini, you akan nampak dia punya drop down menu lah. Ada banyak kat sini. Right. Bila you tekan data analysis dekat sini, dia akan nampak data analysis toolbar. Right. Dia may drop down dollar box. So kita cari Descriptive Statistics dekat sini, Descriptive Statistics, and click OK. Descriptive Statistics and click OK. So dekat sini dia akan keluar, nampak tak Descriptive Statistics dialog box, right? So kita ada dua option, dua section dekat sini. First is input, and second one is output, right? So you tekan dekat input range, right? Input range, you tekan kat hujung ni, right? Sekali lagi tekan kat hujung ni, dekat arrow up ni, right? You select from G1 until G4 until G110. You select amount data, order amount ni lah, right? And click here balik, right? Dekat sini, you boleh klik dekat arrow down ni. And then group by, since kita base pada column, right? So kita akan klik by default column lah. Oops. Right? So since kita tak menggunakan first row label kat ni, kita tak select label, kita uncheck lah. Kalau kita select label, let's say from G3, right? Right, from G3, maksudnya daripada G3 order amount ni, right? And then kita click on label in first row. Kalau kita tak pakai label, kita tak masukkan label G4, right? G4, you faham tak saya cakap apa ni? Maksudnya kita select data daripada G4 to G110, maksudnya tak termasuk order amount ni lah, right? Nama order amount ni, kita uncheck label in first row. Maksudnya kita biar kosong. Kalau kita select daripada order amount sampai bawah, kita check label in first row. And then for output option, so by default dia akan letak new worksheet, right? So tapi kita nak dia display dekat sini, kita tekan output range. Output range maksudnya kita nak letak dekat sini lah. So kita tekan dekat sini arrow up, right? And then let's say saya nak letak kat bawah ni lah. So saya letak kat sini, right? Dekat K113. So saya letak K113, letak sebelah dengan mean dekat sini, right? So I click OK. And then I tekan summary statistic. Summary statistic and confidence interval 95%, right? So I check dua benda ni, right? Dua benda ni I check summary statistic and confidence interval for mean 95%, by default 95% lah. And then click OK. So once you click OK, dia akan keluar the output, right? So the output they give us is mean, sama macam kita dapat ni. Standard error adalah Standard error dekat sini adalah uh, standard deviation divided by square root of n. Maksudnya dekat sini standard deviation is 32517.8 divided by square root of n. N adalah berapa dekat sini? We have count 107. Right, 107. So ini adalah standard error. And this is a median. And this is the mode. Sama saja macam kita dapat tadi kan. Right. And standard deviation dekat sini. Right. And sample variance kita dapat di sini. Kalau nampak ni plus kan. Maksudnya dia amount tu besar kan. So kita boleh tarik lah. Tarik besarkan sikit. So dia akan dapat sama lah. Dan kurtosis adalah yang bila I tunjuk tadi. The peakness of the distribution. Right, lagi tinggi, lagi peak lah. Right. Skewness adalah the distribution punya skewness. Maksudnya kalau kita dapat macam ni, ini dinamakan normal distribution or normally skewed. Right. Ataupun balance distribution. Kalau kita dapat tail dia ke kiri, right, tail dia pemanjang ke kiri, so this is a skewed to the left. And kalau kita dapat skewed, tail dia memanjang ke kanan, right, tail dia memanjang ke kanan, so ini adalah skewed to the right. Skewness selalunya kalau amount dia sama dengan kosong, right? Kalau amount sama dengan kosong, maksudnya dia balance, right? Dia normally skewed, right? Dia macam ni. Kalau amount dia sama dengan any positive value, maksudnya dia skewed to the right. Kalau skewness negative, maksudnya skewed to the left. Boleh faham, ha? And this is the range, right? Yang kita calculate tadi, range. And this is the minimum value and maximum value lah. Dua ni ya. Maksudnya maximum value minus minimum value, kita akan dapat the range. And this is the sum, maksudnya total of all order amount. And this is count berapa banyak data yang kita ada. And this is the confidence level lah. Yang kita type tadi. This is a minimum level, right? So minimum level lah. Dia tak tulis habis lah. Maksudnya this is not correct. Not a correct data, but I know this is a minimal lah because the value is very small. Okay, sebab kita compare dengan mean is 27,000 kan. So this is a 66,000. So this is a minimum value lah of the confidence limit. Okay, so very simple by using data analysis, right? Okay, boleh? Any questions so far? Kalau tak ada soalan, kita rehat 5 minit untuk the next chapter, which is statistical inference. Right? So, nanti kita tengok statistical inference lah. Boleh kita rehat 5 minit? Boleh ke? Ada respons tak? Alright, good. So, kita akan jumpa balik sekarang pukul 11.57, pukul 12.02 minit. Statistical inference, right? So, tadi kita tengok descriptive statistics. So, now we looking at statistical inference or inferential statistics. So, inferential statistics is refer to drawing conclusion about some characteristic of population statistically based on a random sample from that population. Maksudnya, we are collecting a data, let's say from a population. Let's say population ni, capital N equal to 5,000. So, we select one sample. So, this one sample consists of N equal to, let's say 100, right? Sample number 1. So, we find mean of the sample, right? Mean number 1, and S for that sample, so it means standard deviation. Another one, we take another sample, and 2 equal to 100. So we measure mean for sample number 2 and as standard deviation for sample number 2. So from these two sample, can we infer to the result here to represent the population? So we want to refer back to the population. So kita nak buat conclusion terhadap population ni lah, right, based on the sample. So this is what we call as sampling distribution lah, right? So mean should be equal to mu lah, the true population, right? Selalunya adalah sampling distribution, right? So Inferential statistics utilize sample data to make estimation lah, or prediction or decision about the population, right? Hypothesis testing or significant test, right, is a procedure based on the sample evidence and the probability theory to determine whether the hypothesis is reasonable statement, right? So we are looking into hypothesis testing hari ni lah. Right, hypothesis testing is to determine whether the sample does or does not support the statement concerned about the population lah. So in hypothesis testing, we have two statements, right? So the first statement is null hypothesis. This is what we call as null hypothesis. So H null, H naught. Another one is HA or H1. This is what we call as alternative hypothesis. So alternative hypothesis is the claim made by researcher lah, or made by company. For example, let's say a manufacturing company, right? Dia filling water dalam botol kan. So dia claim that dalam satu botol tu, right, botol air, ni tak botol, nampak botol air Coke lah contoh, for example Coke ataupun ni lah mineral water, right? Let's say this is 1.5 liter, right, 1.5 liter kan. So dia filling water dalam botol, right? So they claim that every time machine filling water dalam botol ni, dia exactly 1.5 liter, right? This is the claim, and this is the by default lah. So suddenly a manager claim that, ataupun a customer claim that air dalam botol ni tak sampai pun 1.5 liter, right? Less than 1.5 liter. So this is going to be your alternative hypothesis. For example, kita tengok sini, hypothesis testing, null hypothesis, mu is equal to 1.5 liter. So this is the standard procedure. So the customer claim that the water in the bottle is less than 1.5 liter. So ini by default, this is what we call null hypothesis. This is the claim made by customer. So this is what we call alternative hypothesis. So apa yang kita nak test? Kita nak test null hypothesis. Kita nak test null hypothesis whether the mu ataupun the average water filling in the bottle is equal to 1.5 liter ataupun less than or more than. Ini adalah konsep yang hypothesis testing nak bawa lah, right? So kita tengok step in the hypothesis testing procedure. First step is we need to formulate the hypothesis test by stating the null and alternative hypothesis. Yang ni the first step lah. Second step is we need to select a level of significance. So level of significance means that whether alpha equal to 0.05 or alpha 0.01, 0.02 and so on. Apa maksud alpha ni? Maksudnya we are 95% confidence about the result that we going to test ni. Result yang kita nak test ni, kita ada 95% confidence. Ini kita ada 99% confidence of our result nanti. Boleh faham ah? Maksudnya kita nak test ni. So kita nak test berapa persen confident of the result. Right? We have 95% confident of the result and we are reserving 5%, 0.05% of making mistake or error lah. Error of calculating the result. Boleh faham? So nobody perfect. So we are reserving 5%. So dekat sini we are reserving 1% of making incorrect result. We are reserving 2% of making incorrect result, but we are 98% confidence about our result. Boleh faham? The significant level. Then number 3, right? We need to identify test statistic. Test statistics. So in test statistics, if the population variance is population standard deviation or population variance, right? Population variance is known, right? So dia ada dua part, known and unknown. If the population variance is known, no matter how big the sample size or small the sample size, we're going to use Z distribution. So Z distribution, the formula is Z equal to X bar minus mu divided by sigma over square root of N. Because they are taking from sample, and this is a sampling distribution. If the population variance is unknown, we are going to look at the sample size. If the sample size is less than 30, sample size is more than 30. If the sample size is less than 30, we're going to use T distribution, right? T distribution is X bar minus mu divided by small sample standard deviation divided by square root of N. If the sample size is more than 30, we use Z distribution, X bar minus mu divided by sigma over square root of N. Benda yang sama lah. This one are the same. Right? And then step number 4, we need to make a decision lah. We need to make a decision. So in this decision rule, right? For example, there are two parts. If one tail test, another one is two tail test. So what is the difference between one tail test and two tail test? One tail test is depending on alternative hypothesis. If alternative hypothesis is showing less than the value, less than 1.5, right? For example, so this is one tail test. If population variance, so alternative hypothesis showing mu more than 1.5, this kalau ada less than sahaja, this is one tail test. Kalau less than is a on the left sided. Kalau dia besar, on the right sided. Right? So for two tail test, if alternative hypothesis, right, mu is not equal to 1.5. So kita tak kisah dia sama ada besar atau kecil. So the distribution will be two-sided. Right? So either right or left. Right? Boleh And then once kita dah identify the decision rule, and then we make a decision lah and conclusion. So number 5, decision and conclusion. Right? So macam mana nak make a decision? So let's say you are using this critical value method. So let's say skew to the this is a one tail test. Yang pertama, yang kedua ni kan, right? So is the area is on the right. So ini dipanggil area yang kita shade ni kita panggil rejection area. And this one we call as acceptance area. So kalau the value of test statistic dekat sini falls under acceptance area, right? So kita akan accept sorry, I tulis betul-betul, accept null hypothesis. If the value of Z dekat sini test statistic ni falls under rejection area, we're going to reject null hypothesis and accept alternative hypothesis. When we accept alternative hypothesis, we reject we accept null hypothesis, we reject alternative hypothesis. When we reject null hypothesis, we accept alternative hypothesis. We make a conclusion based on the decision lah. Okay, so now let's look at one sample hypothesis testing. So before we go there, boleh faham apa yang I draw ni? Boleh? Right, good. So now, macam tadi I cakap, one sample hypothesis testing. So kalau kita tengok dekat sini, ini dalam buku, you boleh tengok dalam buku benda yang sama. So this is 1, 2, 3. This is 1, 2, 3 and 4. So this is an example of the statement. Kalau kita tengok dekat sini, buku ni dia bukan daripada statistician, right, daripada business lecturer. So they make a mistake here. So null hypothesis should always equal. Dia tak boleh ada less than. So it should be equal. Right? It should be equal. Right? So sama dekat atas ni betul. You make a correction. So nombor 3 dengan nombor 4 ni mesti sama dengan. So mu naught ni adalah number lah. Tadi kita kata 1.5 liter. Right? So kalau dia more than, less than, more than, less than, kalau dia more than, sepatutnya dia lebih besar lah. So this one example of alternative hypothesis, mu more than mu naught. In this example, alternative hypothesis mu is less than mu naught. Right? So this is a difference. So critical region adalah yang shaded area ni. Critical value, so ini adalah pemisah dia, dia punya point ni. This is what we call critical value. Sama juga dengan ni lah. Ini yang the point that separate between acceptance region and rejection region. So this is what we call acceptance region. This is what we call rejection region ataupun area lah, benda yang sama. So I hope you understand the area, right, yang kita nak select ni. Kalau dia null alternative hypothesis more than, so it should be on the right hand side. If the alternative hypothesis is less than, it should be on the left hand side. If the alternative hypothesis shows that not equal, right, we don't care whether left or right, so we're going to use a two-tailed test. So this is the area, left and right. And of course, alpha we need to divide by 2 lah, right, because it share the same area lah. And this is the acceptance region, rejection region, right? Okay. Now, let's look at type 1 error and type 2 error. Nanti you boleh baca balik semula. And this is the function of alpha. 0.05 means that we are reserving 5% of making type 1 error and type 2 error lah. Right? Type 2 error means that we found that null hypothesis is true, but actually null hypothesis is false. So this is what we call as type 1 error. And type 2 error is we found that in our result null hypothesis is false, but in actual null hypothesis is true. So kita reject, kita kata type 2 error lah. So Now, one sample hypothesis testing, tadi I dah tunjuk which one to use, Z or T distribution. Right? So, now kita tengok example this one, Excel function. Right? So, Excel function ni muka surat berapa? Boleh tengok balik. Muka surat... muka surat 82. Right? You boleh tengok dalam muka surat 82. Benda yang sama lah. Right? I just copy back. Right? So, kita akan pakai this one to calculate the Z value and to calculate T value and finding critical value and critical value for T value and P value as well lah. Now, we look at example number 1, which is fast food restaurants. Right, fast food restaurants. Kita tengok dalam data set ni, I dah bagi dekat you. Right. So, fast food restaurants. So, dekat sini kita ada customer and time. Right. Waiting time. Right. Kita tengok baca soalan dulu. So, fast food restaurant claim that customer order will be served within 8 minutes. Right. They claim that the food will be served within 8 minutes. So the manager restaurant received some complaint of the waiting time. The manager collects sample of 50 customers waiting time in Excel, yang kita akan tengok nanti. So at 5% level of significance, maksudnya 0.05 alpha, using the critical value approach and p-value approach for hypothesis testing, is there evidence that the sample mean waiting time to place an order support the claim made by the restaurants? So, maksudnya, apa yang kita nak cari kat sini? Okay. First, kita kena type hypothesis testing. Right. Hypothesis statement. Hypothesis statement. Right. Null hypothesis, mu is equal to 8 minutes. Right. Alternative hypothesis, mu is not equal to 8 minutes. Maksudnya tak sama dengan 8 minit lah. So this is the claim. Right. Right. So dekat sini kalau kita tengok, alternative hypothesis is not equal. It's supposed to be two-tail test. Right? Supposed to be two-tail test. So our next step, this is the first step. Next step is significant level. So alpha is equal to 0.05. Mana kita tahu? Kita tengok daripada soalan lah. 0.05. So next, kita tengok number 3. Test statistic. Test statistic without S. So, based pada apa yang I cakap tadi, mana I tulis this one, right? If the population variance is unknown, right? So, kita tak tahu the population variance dekat sini, right? Dekat soalan ni, kita tak tahu population variance unknown. When the sample size is less than 30, use T distribution. When the sample size is more than 30, use Z distribution. Right, kalau kita tengok dalam buku ni, dia menggunakan T distribution kan. So, sebenarnya buku ni salah lah. Okay, sebab apa? Dalam buku surat 84, dia menggunakan T distribution, T statistic. Right, so kalau kita tengok dekat sini, the rule yang I keluarkan dekat sini, right. So, population variance unknown. Kita tak tahu population variance. Dalam buku ni dia tak bagi, dalam example ni dia tak bagi tahu what is a population variance. Right, dia tak bagi tahu population variance. So, since we don't know the population variance, we look at the sample size. When the sample size is more than 30, use Z distribution. If the sample size is less than 30, use T distribution. So, we're going to use Z distribution lah. Z equal to X bar minus mu divided by sigma over, divided by S over, S over, mana tu ni? S over square root of N. So, I buat perubahan sikit lah. This is S over square root of N lah. Sebab kita tak tahu the population variance. Right? So, now, the sample size here, kita ada 50. Right? Kalau kita tengok, kita buat kolom lah. Let's say alpha is 0.05. Right? This is what we want to know. Right? And then, we have N. N dekat sini berapa? Macam mana nak tahu N? Kita menggunakan count lah. Count from 8 until 53 ni kan. So, tutup kurungan. So, we have 50. Boleh ikut And then we have mu. Mu kita 8 kan. So, kita type 8 kat sini. And then we want to know the average waiting time. Right? Average waiting time. So, average waiting time, kita type average. Right? And then select semua ni lah. Average waiting time. Tutup kurungan. Kita akan dapat 8.02. Sama macam buku Betul? And then kita tengok dekat sini. Kita kena ada. Kita dah ada dekat formula ni. Kita tengok formula Z distribution ni. Dekat sini we have the value of X bar kita ada. The value of this one tak boleh pakai this one. Okay. Kita dah ada value of X bar dekat formula ni kan. Right. Kita ada Z equal to X bar minus mu divided by S over square root of N. So we already obtained X bar, which is this one. Mu kita dah obtain, which is this one. And N kita dah tahu, which is 50. And we need to calculate S lah, standard deviation. So, standard deviation of waiting time. Right? So, STDEV, yang tadi kita dah belajar kan? S. Right? So, kita highlight this one lah. From here to here. Right? And tutup kurungan. Kita akan dapat the standard deviation is 1.34. Right? Since dalam formula ni ada square root of N kan? So, kita type square root of N. So, it should be SQRT of N. N is 50. Right? So, kita dapat 7.07. Right? So, then kita akan menggunakan Z-test. Right? So, Z-test, kita apply this formula. Right? Tutup kurungan. Waiting time minus average waiting time X bar minus mu, tutup kurungan, divide by standard deviation bahagi square root of N, tutup kurungan. So we will get 0.149. Sama lah value yang kita dapat tu sama. Tapi yang you kena ubah adalah Z-test T-test kepada Z-test. Boleh Boleh semua dapat? Please response. Square root of N ni. Okay. Sebab kita tengok formula ni kan. Ada square root of N. So we just type square root SQRT. And kita select N ni lah. N adalah 50. Right. Kita dah calculate mula-mula tadi kan. Right. And then Z-test, kita menggunakan formula ni. Right, Z. X bar, which is E7 minus mu adalah E6. Right, kita bahagi. And buka kurungan. E8 maksudnya standard deviation E8 ni. Dekat sini E8. Right. bahagi dengan square root of n. Square root of n is E9. So, kita akan dapat the value of Z. Okay? And then, once kita dapat dekat sini, 0.10. So, kita tulislah kat sini. So, this one is 0.1049. Right? So, this is the value. And step number 4 is critical region. So, the critical region, kita tengok dekat alternative hypothesis. The alternative hypothesis is not equal, kan? So, it is a two-tail test, right? It's a two-tail test. This is the region. So, kita tahu ini adalah rejection area. And this is also a rejection area. Boleh? And this is a acceptance area. So next, kita nak tahu what is this area, right? This one, apa ni? Dia punya point Z alpha divided by 2. And this is Z alpha divided by 2. Sebab dia ada dua part, alpha mesti bahagi dengan 2 lah. This is our alpha, kan? So next, kita nak cari critical region. So critical region, kita tengok balik the statistic Excel punya formula. So to find the critical Z value, so kita menggunakan norm.s inverse 1 minus alpha. So kita type in lah. So norm dot s dot inverse, right, 1 minus alpha. Our alpha is 0.05 dekat sini lah. So we will get 1.64. So this is the value 1.64, and this is the value of negative 1.64. Right, dia mesti sama kalau two-tail test. Right? They can share the same thing, but the only difference is the positive and negative sign lah. Right? So the next one is kita tengok p-value. P-value, kita tengok balik dalam ni. P-value for two-tail test, this is for t-test. P-value for two-tail test, z-test. Right, so kita akan pakai 2 multiply with 1 minus norm.s distribution negative z true. Right, so kita type dekat sini lah. Negative equal to let's say, tapi kita tengok dalam buku, kalau dia kata z is more than 0, kita akan pakai the second one, negative z. Right, if dia akan pakai benda yang sama lah. So 2 multiply with 1 minus norm dot s distribution, right, tutup kurungan, buka kurungan, negative z, which is negative z 11, right, and then true, kita ambil true lah, true, and tutup kurungan. So we will get kalau bond negative, yeah, it should not have negative value dekat situ, kan? Kalau kita tengok the formula, right, dalam buku dia ada negative z, kan? But actually we don't need to put negative value dekat situ, just alpha value, right? So dia akan dapat 0.05. 0.91, right? Okay, I will explain later, okay? So now, setakat tu saja yang kita nak, right? So tak sama dengan muka surat 84 sebab 84 dia menggunakan T value, dia salah daripada mula, right? So the next step, right, kita tengok dekat sini, right? So now step number 5. Step number 5, our decision rule, right? If Z calculated apa dah? Inilah. Ini adalah Z calculated. Z calculated is lies under acceptance region. Null hypothesis is accepted. Right? So this is the rule. So if the value of Z calculated lies under acceptance region, null hypothesis is accepted. So our decision, step number 6, decision, since Z calculated, right? Z calculated ni berapa? 0.1 kan? 0.1 is somewhere here lah. 0.1. So kalau dia, this is 0, right? 0.1 somewhere here. So it lies under acceptance region. Null hypothesis is accepted. Right? So since number 7, conclusion, since null hypothesis is accepted, we have 95% confidence that the mu is equal to 8. Right? The average waiting time is equal to 8 minutes. So this is based on the critical region. So kalau kita nak tengok lagi satu, based on the p-value. Right? So decision rule. If the p-value is less than alpha, our alpha is 0.05, right? Null hypothesis is rejected. Oops. Rejected. So if the p-value is more than alpha, which is 0.05, null hypothesis is accepted. So our decision, so since the p-value is equal to 0.9 berapa? 0.91, 9164, is it? Right? So more than alpha, right? More than alpha, which is 0.05, null hypothesis is accepted. Dia mesti sama. Dua-dua method mesti sama conclusion dia. So the conclusion are still same lah. Since null hypothesis is accepted, we have 95% confidence that average waiting time is equal to 8 minutes. Boleh faham? So this is the procedure. Okay? So in your report nanti, you kena buat macam ni lah. Right? Boleh? Okay? Ada soalan tak? Okay. I think kita ada banyak lagi dekat sini. Kita baru sentuh one sample. Test kan. Kita tengok tadi two-tail test. Sepatutnya dekat sini two-tail test lah. Dia bukan one-tail test. Tapi nanti kita akan tengok one-tail test example yang kita akan tengok satu lagi lah. Right? So kalau one tail test macam mana? So let's say less than 8 minute ataupun more than 8 minute. Nanti kita akan ubah sikit kat sini nanti. So I think masa pun tak cukup. So kita continue this chapter on next week, next class lah. To sample hypothesis testing, one way ANOVA, right? And t-test, right? So I think benda yang sama juga. Let's say you boleh buat sendiri, boleh baca sendiri kot ini Iswan, right? Do you have any problem here? Tak ada problem? Ada you boleh faham apa yang I jelaskan? Kalau you boleh faham, I teruskan sedikit next week lah, next class lah. Next class kita akan tengok two sample hypothesis testing using paired sample and unpaired sample. Another one is analysis of variance. Right? Boleh? Ada soalan tak? Okay kan? So next class kita akan jumpa 20. Ya, ya. Yes. Itu bukan Microsoft Office. Itu Open Office kan? Cuba share balik semula. Let's say, let me see. Microsoft Office dia tulis Excel lah. Tak, kalau Microsoft Office, you need to use student email address. Sebab UiTM bagi full access untuk full license lah untuk Microsoft Office. You boleh guna you punya student address, email address. Kalau tak sure, yep. Can you share?